Our objectives in this lesson are the following. Identify the steps in hypothesis testing and solve problems involving test of hypothesis on the population mean. Let's have a quick activity. Draw thumbs up if the statement is true and thumbs down if false. Number 1. The null hypothesis is what you hope or believe to be true. This is thumbs down. What you hope or believe to be true is the alternative hypothesis. Number 2, the alternative hypothesis is a statement that there is no significant difference between hypothesized and computed values. This is thumbs down. The statement that there is no significant difference is for null hypothesis. Number 3, given h sub 0 mu is equal to 15, h sub 1 mu is not equal to 15 is an example of one-tailed test. This is thumbs down. Since we have not equal to here, this is a two-tailed test. Number 4, one-tailed is used when the alternative hypothesis assumed a less than or greater than value. This is thumbs up. Number 5, the level of significance is the probability of error used in deciding whether to reject the null hypothesis or not. This is thumbs up. Number 6, the t-test is used when n is greater than or equal to 30 and sigma is unknown. This is thumbs down. When sigma is unknown but our n is greater than or equal to 30, we use z-test. Last one, the notations. X bar and small letter s are parameters. X bar is a sample mean. Small letter s is a sample standard deviation. This pertains to the sample. Therefore, these are not parameters. So we have thumbs down. Here are the steps in testing hypothesis on population mean. Number 1, identify pertinent information such as population mean, standard deviation, sample size, and level of significance. Step 2 is state null and alternative hypothesis. Number 3, decide on the appropriate test statistic and compute its value. Number 4, delineate regions of rejection and non-rejection. And last one, make your conclusion and state the interpretation. Actually, hypothesis testing starts with stating the hypothesis. I personally add this first step so that the rest will be conducted smoothly. Just follow the steps given by your teacher. What matters is at the end, we have the same conclusion and interpretation. Let us have the first example. A principal at ABC Senior High School claims that the students in his school are above average intelligence. A random sample of 30 students has a mean IQ score of 108. The mean population IQ is 100 with a standard deviation of 15. IQ scores are normally distributed. Test the claim at 5% level of significance. Is there sufficient evidence to support the principal's claim? Step 1, we have to identify the pertinent information here. As I suggested, always start with the sample size. We have here a random sample of 30 students. So n is equal to 30. Mean IQ score of 108. This mean of 108 pertains to the sample, so this is sample mean equals 108. The mean population IQ is 100, so mu is equal to 100, with a standard deviation of 15 pertaining to the population, so this is sigma. Test the claim at 5% level of significance. So alpha is equal to 5% or 0.05. Step 2, let us state the hypothesis. Let us look for our keyword here. We have here above. So this means it goes to the alternative hypothesis. H sub 1, mu is greater than 100. We use greater than for the keyword above. For the null hypothesis, we have here mu is equal to 100. Step 3, let us identify the appropriate test statistic and then afterwards let us compute for it. Since we have here the population standard deviation and our sample is equal to 30, we are going to use z-test. Let us recall our formula for z-test. Let us substitute our values here. Let us encode this in the calculator in this way or in this way. And this will give us z is equal to 2.921, rounded off to the nearest thousands. Step 4, let us delineate the regions of rejection and non-rejection. Since we decided to use z-test, we're going to recall our z-critical values. Let us recall also our alternative hypothesis, and that is mu is greater than 100, as well as our level of significance. So greater than, this is our right-tailed test. 0.05 level of significance, so our critical value is 1.645. Let us sketch the curve. Locate 1.645, that is somewhere here. Label that. Shade the right tail of our curve. This is our rejection or critical region. Step 5, let us make our conclusion and interpretation. But before that, recall first the computed z-value. Let us locate 2.921 in our graph. If this is 3, then somewhere before 3, there is 2.921. And it lies within the rejection region. So our conclusion will be reject the null hypothesis at 0.05 significance level. Now, for the interpretation, since we reject, it means we have enough or sufficient evidence to do so, and we are going to support our alternative hypothesis. Let us write that in words. There is sufficient evidence because we reject to support the claim that the students from ABC Senior High School have above average intelligence level. By the way, when we reject the null hypothesis, it does not necessarily mean that the null hypothesis is incorrect or that the alternative hypothesis is correct. We reject because we have enough or sufficient evidence to reject it based on the result of the test that we conducted. Remember the criminal trial in a court? The null hypothesis here is that the defendant is innocent. If the defendant is convicted, meaning we reject the null hypothesis, he was convicted because there is enough evidence in the trial to prove that he is guilty. Let us have another one. A pharmaceutical company claims that the effect of their paracetamol lasts at least 4 hours. You suspect it's lesser than that. So you surveyed 15 of your friends randomly. It revealed an average of 3.8 hours with a standard deviation of 0.75 hours. Do you think the company is overconfident with their product? Test the claim at 0.10 level of significance. Step 1, let us identify the pertinent information here and we'll start with the sample size. It says here you surveyed 15 of your friends randomly. So N is equal to 15. It revealed an average of 3.8 hours. So this average, this mean refers to the sample. So this is our sample mean. With a standard deviation of 0.75 hours, also referring to the sample, so this is a small letter s. So this means these 4 hours here will be our population mean. And we have here 0.10 level of significance. Alpha is equal to 0.10. Step 2 for our hypothesis. Let us look for the keyword. It says here, at least. When we say at least, that is greater than or equal to 4. And greater than or equal to goes to null hypothesis. So H sub 0, mu is greater than or equal to 4. And for our alternative hypothesis, let's look for another keyword here. It says lesser. Alternative hypothesis, H sub 1, mu is less than 4. Step 3, let us identify the appropriate test statistic. We have here sample standard deviation and our sample size is less than 30. Therefore, we're going to use t-test. Let us recall the formula for t-test and let us substitute our values here. Encode this in your calculator and this will give you t is equal to negative 1.033, rounded off to the nearest thousandths. Step 4, delineate regions of rejection and non-rejection. Since we decided to use t-test, we're going to need our t-table. Let us recall our alternative hypothesis, H sub 1, mu is less than 4, and our level of significance. This is less than, so this is 1 tail. At level of significance 0.10, so this column. Let us also recall our sample size, which is 15, and 15 minus 1 is 14. That will be our degrees of freedom. So the critical value is 1.345. Let us sketch the curve. Locate 1.345. This is left tail, so on the left side. This is negative 1, then somewhere here is negative 1.345. Shade the tail, and this is our rejection or critical region. Step 5, let us draw our conclusion and state our interpretation. Computed t-value, negative 1.033. If this is negative 1.3, then to the right of it, maybe here, is negative 1.033. And it lies within the non-rejection region. Therefore, our conclusion will be fail to reject the null hypothesis at point 10 significance level. Since we fail to reject, it means we do not have enough or our evidence is insufficient to reject the null hypothesis and support our alternative hypothesis. In words, this will be there is insufficient evidence. Again, because we fail to reject, it means we have insufficient evidence to support the claim. And what is the claim? That the effect of the paracetamol lasts less than 4 hours. When you conclude to reject the null hypothesis, it means you have sufficient evidence. So when you fail to reject, that means you have insufficient evidence. And then, take a look at your alternative hypothesis. This means what? This means that the effect of the paracetamol lasts less than 4 hours. When we say fail to reject null hypothesis, it does not necessarily mean that the null hypothesis is true. That's why we don't use accept the null hypothesis. Instead, we use fail to reject because we don't have enough evidence to reject it based on the test that we have conducted. Going back to the example, criminal trial in a court where the null hypothesis again is that the defendant is innocent, and let us say we fail to reject it. It does not mean we accept that he is innocent. We fail to reject because there is no enough evidence from the trial to prove that he is guilty. Let's have another activity, choosing the right one. Choose the best answer to the following questions or statements. Number 1. What is the last step in hypothesis testing? This is letter C. Make the conclusion and interpret it. Number 2. What should be the decision if the computed value lies in the critical region? Correct answer is we reject the null hypothesis. Number 3, according to www.statistica.com, the average monthly salary in the Philippines as of 2020 is 45,000 pesos. Which of the following represents the null and alternative hypothesis? Which one? A, B, C, or D? Correct answer is D. Number 4, in a right-tailed test, what will you do if the critical value is less than the computed value? Let's use a picture to visualize it. So here is the critical value, and here is the computed value. The critical value is less than the computed value. So what are you going to do in this case? Reject the null hypothesis since the computed value lies in the rejection region. Number 5, what does it mean if a result is said to be significant at 5% level? This means there is a 5% chance that the true null hypothesis is rejected. Number 6, what should be the decision if the computed value is 2.567 and the critical t-value is 3.505? General rule, if the absolute value of the computed value is less than the absolute value of the critical value, we fail to reject the null hypothesis. Number 7, which value separates the critical region from the non-critical region in a normal curve when testing hypothesis? The answer is letter C, the critical value. Last one, which of the following statements is true when the null hypothesis is rejected? Why do we reject? We reject because there is sufficient evidence against the null hypothesis. Let us do extra challenge. On records, the average weight of grade 11 students is 60.8 kilograms. However, the clinic coordinator believes it is different now. So he weighs 25 randomly selected grade 11 students. It turned out that the average weight is 64.5 kilograms with a standard deviation of 5.8. Is there enough evidence to suggest that the average weight has changed? Step 1. Let us identify the pertinent information. Start with the sample size. He weighs 25 randomly selected, so N is equal to 25. It turned out that the average weight is 64.5, referring to the sample, so this is our sample mean. With a standard deviation of 5.8, also referring to the sample, this is the sample standard deviation. So it means this 60.8 kilograms here is our population mean, which is correct because it says here on record. So this is based on previous study. How about the level of significance? Is there anything mentioned in our problem here? There is none. If that is the case, we set our level of significance equal to 5% or 0.05. This is the most commonly used level of significance. So if it is not stated in the problem, we set alpha equal to 5%. Step 2. For the hypothesis, let us look for the keyword. We have here different. This goes to our alternative hypothesis. So we have H sub 1. Mu is not equal to 60.8. Not equal to because of the keyword different. Our null hypothesis will be H sub 0. Mu is equal to 60.8. Step 3. Let us analyze. We have here sample standard deviation and our sample is less than 30. So we're going to use t-test. Recall the formula and substitute our values here. And encode this in our calculator. This will give us a value of 3.190, rounded off to the nearest thousandths. Step 4, the regions of rejection and non-rejection. Since we decided to use t-test, let us recall our t-table. Our alternative hypothesis again, mu is not equal to 60.8 and our level of significance is 0.05. Not equal to, this is a two-tailed test at 0.05, so this column. Our sample is 25 minus 1 is 24. This is our degrees of freedom. So the critical value is 2.064. Sketch the curve. Locate our critical value. It is somewhere here, 2.064. This is two-tailed, so we're going to do the same thing on the left tail. Just after negative 2, we have negative 2.064. Shade the tails of the curve, and these are our regions of rejection. Step 5, let us draw conclusion and state our interpretation. Our computed t-value, 3.190. If this is 3, then somewhere to the right of it is 3.190. Since it lies in the rejection region, our conclusion is to reject the null hypothesis at 0.05 significance level. Because we reject, it means we have sufficient evidence and we're going to support our alternative hypothesis, which is the student's weight has changed. For the summary, again, here are the steps in testing hypothesis on population mean. Now, it is time to check your understanding. Pause this video for more time. Let us answer. In the past, teachers prepare lesson plan in 90 minutes on average. With the trend in technology, the principal believes that it has changed. He took a sample of 40 teachers and it revealed a preparation time of 85 minutes on average with a standard deviation of 18 minutes. Is there enough evidence to suggest that technology has affected the time it takes for teachers to prepare a lesson plan? Step 1, let us identify the pertinent information here. A sample of 40 teachers, so n is equal to 40, revealed a preparation time of 85 minutes on average, referring to the sample, so sample mean x bar is equal to 85, with a standard deviation of 18 minutes, also referring to the sample, small letter s. So it follows that this 90 minutes here is our population mean. And it is correct because it says here in the past. So it is based from previous study. Once again, there is no level of significance mentioned, so we are going to use alpha is equal to 5% or 0.05. Step 2, for our hypothesis, let us look for a keyword, and we have here change. No particular direction if it is less than or greater than. This will fall in our alternative hypothesis. H sub 1, mu is not equal to 90. Our null hypothesis would be H sub 0, mu is equal to 90. Step 3, let us decide on the test statistic. We are given sample standard deviation, but our sample size is greater than 30, so we're going to use z-test. Recall the formula and substitute our given here. Encode this in our calculator. This will give us negative 1.757 rounded off to the nearest thousands. Step 4, since we decided to use z-test, let us recall our z-critical values. Our alternative hypothesis, mu is not equal to 90, and our level of significance is 5%. Not equal to, so this is a two-tailed test. At 0.05, our critical values are positive and negative 1.96. Let us sketch our curve. Locate positive 1.96, that is right before 2. Label that. This is two-tailed. We're going to do the same thing on the left. Negative 1.96. Shade the tails of the curve. These are our regions of rejection. Step 5, to draw conclusion and make interpretation, let us recall first our computed z-value. Locate that in our graph. If this is negative 1.96, then to the right of it is negative 1.757. And it lies on the non-rejection region. Therefore, the conclusion will be fail to reject the null hypothesis at 0.05 level of significance. So our interpretation, since we fail to reject, we have insufficient evidence to support the claim. And what is the claim? That technology has affected the time it takes for teachers to prepare a lesson plan. Gets? Our next lesson is formulating null and alternative hypotheses on a population proportion.